Okay, here we've got an example of one of the commonest approaches we get to probability, which is a two-way table. So we have to enter the data that's given. So we know there's a total of 50 students, so the grand total down here is going to be 50. Okay, we know that 30 students are studying maths, so the total number of maths students is 30. And we know that 10 students are studying, 25 students are studying English. And we know that 10 students are studying both maths and English. So that 10 is the first one that actually goes in the body of the table. So these 10 study maths and English. Okay, since 30 study maths altogether, that means there must be 20 here studying maths but not English. And working this way, I can tell that 25 must be made up of 10 plus 15. And now if I look at these three numbers here, they add up to 10 and 20 is 30. This makes it 45. So the total is 50. There must be another 5 here. Various ways of getting to that. So this is 25, which I could get by subtraction here, or I could get it by adding here. So the table works. Everything adds up to 50. Okay, so that's the table filled in. Now I've got to find the probability that a student chosen at random is studying maths or English. So this is going to be a fraction, okay? The bottom number of the fraction is always how many students overall could have been chosen. So we're just choosing a student at random. So that could be any one of the 50. Okay, and then they have to be studying maths or English. So this person's studying maths and English. Sorry, these 10 people. These people are studying English. These people are studying maths. So altogether, I've circled all of the people who are studying maths or English, or both. Okay, or in probability always means one or the other or both. So I need a total of 45 over 50. And I can say this is the probability of maths or English. And so cancelling that down, I'm going to get 9 over 10 or 0.9. Any of these answers would be acceptable. Okay, now it says we could use a formula. That formula that we can use, in the formula book it says that the probability of A or B equals the probability of A plus the probability of B plus the probability of minus the probability of A and B. And we can check that gives the same answer, but we can also see why this rule works. Because, okay, for the probability of A or B, okay, that's these three cells in the table here, and I can see that if I were to add the 30 to the 25, then that would actually give me an answer of 55, not 45, because I'd have included the 10 twice. So what I have to do, if I want to use the 30, that's the overall probability, or the number of students doing maths, and the 25, I would have to add those together, but then I'd have to make allowance of the fact I've counted these 10 twice, so I'd have to take them away. So applying the formula, the probability of A, well, apply this, the probability of maths or English. So it's going to be the probability of maths plus the probability of English minus the probability of both maths and English. So probability of maths is out of 50, 50 on the bottom, and the chance you do maths is 30 out of 50, and the chance you do English instead would be this total 25 over 50. But I have to take away the probability of doing both. That's this 10 that's been counted twice out of 50. And that would be 55 minus 10 is 45 out of 50. And lo and behold, we've got the same answer as before. So this formula here can be useful. It's in the formula book, but very often you can work directly from the table.